Alright, so here we have another chemical equation. We want to, once again, first determine what type of reaction it is. If you remember from the first video, the easiest way to do this is by looking at the plus signs and where they're located at. So on here, I have plus signs on both sides of the equation. Since there are plus signs on both sides of the equation, I'm going to have some type of displacement reaction. It's either going to be single displacement or double displacement. So then I take a look at my first term on my reaction side and my first term on my product side. Whenever I look at this, all I do is I try to determine how many elements are moving out or moving into this term. So if I compare the two, all I notice is that if you compare this first term to the second, the only thing that's different is that the oxygen has moved out. Nothing has moved in to take its place. All that's happened is the oxygen's moved out. Since only one element has moved, it is a single displacement reaction. So now that I've determined what type of reaction it is, I'm going to balance the equation. The best way to do that is to get yourself organized. List each of the elements that are located on both sides of the reaction. So I have Sn, which is tin, is the element. I have oxygen, and I have hydrogen. On the other side, it's going to be the exact same. Tin, oxygen, and hydrogen. So now I'm going to count up to see how many I have of each element. So on my reactant side, I have 1 tin. And on my product side, I also have 1 tin. On my reactant side, I have 2 oxygen. On my product side, I have 1 oxygen. On my reactant side, I have 2 hydrogen. On my product side, I have 2 hydrogen. This one's pretty easy to know where to start because there's only one term, one element that's out of balance, and that's my oxygen. In order to make the oxygen balanced, I need to go to my product side and multiply it by 2. So 2 times this 1 oxygen changes that to 2. However, it also changes the number of hydrogen I have. So now I have 4 hydrogen. So I got to go over to my reactant side. On my reactant side, since the oxygen's balanced, the tin is still balanced, I'm going to look at my hydrogen. And all I need to do is multiply by my hydrogen by 2. 2 times 2 gives me 4 hydrogen. So now it appears balanced. But I always want to double check. This just seemed a little too easy, but let's double check to see if we are still balanced. I have 1 tin and 1 tin right here, so that's balanced. I have 2 oxygen and 2 oxygen on this side, so my oxygen are balanced. I have 4 hydrogen and 4 hydrogen, so my hydrogen are balanced. So this equation was very simple, didn't require a lot of going back and forth. Sometimes you'll get equations like that, sometimes you might have to go back and forth several times. But this equation is balanced.